This story cannot be told in full. You can only approach its edge and watch as it disappears into the darkness, where no human will ever reach. This is the story of a system that encompasses half the planet, a system with its own cities and its own deserts, its own predators and its own mysteries. A system that existed long before the current configuration of continents and will outlast everything that is happening now in the geological sense of the word. The only question is what it will look like afterward. On a map, it is simply a blue patch between two shores. In reality, a three-dimensional structure, breathing every few seconds and pumping water in volumes impossible to imagine on a human scale. It has a heart, a conveyor belt of warm and cold layers that heats half of Europe and has been running for millennia. It has lungs, fields of plankton that draw carbon dioxide from the atmosphere. It has memory, layers of sediment on the floor that record the last 100,000 years of the planet's climate, temperatures spanning tens of millions of years, pollen from plants long extinct. And it has inhabitants, creatures that sing complex songs and change them synchronously across an entire population. Creatures that live for 500 years and are in no hurry. Creatures that do not know what sunlight is because they were born at a kilometer's depth where there is no light and never has been. Creatures whose fishing humanity closed 30 years ago and they still have not returned. This system survived continental collisions and ice ages. Now it is meeting something new. Can a place larger than any country and older than any civilization be preserved? Can we hear an ocean that in the last half-century has grown too noisy for whales to hear each other at their former distance? And if the pressure is removed, does nature truly return in full, or only its reflection? Listen, this story is about what the Atlantic remembers longer than humans know how to count. This ocean breathes, not metaphorically but literally. Every few seconds its surface rises and falls, by centimeters in one place, by tens of meters in another. In a rhythm that determines the weather on half the planet, drives fish across the equator, feeds birds on the cliffs of Scotland, and carries turtles from the Caribbean to the shores of Portugal. The Atlantic Ocean is the second largest on Earth, but first in its influence on the lives of people and animals. It separates two worlds and at the same time connects them, through currents, through migrating animals, through clouds that rise from its surface and fall as rain on the forests of the Amazon. This is not simply water between continents, but a system that keeps the planet alive. When dinosaurs walked the Earth, the Atlantic did not exist. There was a single landmass, the supercontinent Pangaea, which began to break apart about 700 million years ago. North America and Europe drifted in opposite directions. South America and Africa followed. Between them appeared a rift into which water poured. The rift widened centimeter by centimeter, year by year, and after millions of years became what we now call the Atlantic Ocean. The process has not stopped. The floor of the Atlantic continues to spread today along the mid-Atlantic ridge, which runs through the entire ocean from north to south. The rate of expansion is about 0.0 centimeters per year. In 7 million years, the Atlantic will be roughly 0.5 kilometers wider. The mid-Atlantic ridge is a mountain system about 16 kilometers long, the longest on Earth. It is almost entirely underwater, except for a few points where it rises above the surface and forms islands. Iceland, the Azores, the Cape Verde Islands. Iceland literally stands on the ridge. Geologically, it sits directly on the boundary of two tectonic plates that are pulling apart beneath it. Where the plates diverge, magma breaks through from below, forming new crust. Iceland is a place where you can watch the birth of ocean floor in real time. A geologically young ocean already governs the climate of half the planet, primarily through a single current. The Gulf Stream is not simply a warm current in the Atlantic, it is the heating system of half of Europe. Without it, London would have the climate of Moscow, Norway would be locked in ice up to the latitude of St. Petersburg, and Ireland would resemble Siberia. The Gulf Stream originates in the Gulf of Mexico, hence the name, and carries warm water northward along the eastern coast of North America, then turns east toward the shores of Europe. The volume of water it moves is about 3 million cubic meters per second, 20 times the combined discharge of all the rivers on Earth. This is impossible to imagine on a human scale. It is simply a fact one must live with. The Gulf Stream is part of a broader system called the Atlantic Meridional Overturning Circulation, or AMOC. This is an enormous conveyor belt, continuously moving water throughout the Atlantic basin. At the surface, warm water travels northward. In the North Atlantic, it cools, becomes denser and heavier, and sinks to the bottom. Cold, deep water slowly creeps southward along the floor. In the tropics, it warms again and rises. The cycle closes. Water that sinks to the bottom of the North Atlantic today will surface somewhere in the Pacific Ocean a millennium from now. This is the planet's circulatory system, and the Atlantic is its heart. The surface of this ocean is not a quiet place. It is a constantly changing three-dimensional structure of waves, currents, eddies, and fronts. Waves in the open ocean can be formed by a storm 1,000 kilometers away and arrive at shore days after the storm itself has long subsided. This is called swell. Surfers in Morocco catch waves born in a hurricane off the coast of Newfoundland. The Atlantic remembers storms that ended a week ago. Storms in the North Atlantic are among the most powerful on the planet. In winter, deep cyclones form over cold water and warm air from the south, carrying winds above kilometers per hour and waves 20 meters high or more. A 20-meter wave is the height of a 6-story building. It moves, it breaks. This is not a backdrop. It is a physical reality in which everything that lives in the Atlantic must somehow know how to exist. In this reality live creatures that cannot be spoken of as mere animals. All male humpback whales in a single region sing the same song. Within a few months, the song changes, and all of them synchronously switch to the new version. This is not instinct. This is culture, something that whales learn from one another. The humpback whale in the Atlantic is one of the most studied and simultaneously most mysterious mammals in the world. Studied because it is easy to find. It is large, often leaps from the water, and sings. Mysterious because its song still has no complete explanation. Males sing for hours, sometimes for days. Long, complex, shifting compositions. Changes in the song spread from west to east, like a musical fashion sweeping first one population, then its neighbor. This is cultural transmission of information, making humpback whales cultural beings in the most literal sense of the word. The humpback whale migrates between winter reproductive grounds in the tropics and summer feeding grounds in higher latitudes. In winter, the Caribbean Sea, the Dominican Republic, Bermuda. In summer, waters off Iceland, Norway, the Grand Banks of Newfoundland. These are thousands of kilometers each way, covered by the whale while barely eating. In summer, it accumulates fat, feeding on krill and small fish in productive cold waters. In winter, it lives on those reserves while seeking a mate. Its entire annual cycle is governed by this rhythm. The humpback whale breaching from the water is a sight that everyone who has watched ocean documentaries has seen. The explanation for this behavior remains a matter of debate. One theory, communication. The sharp impact on the water produces a sound audible for many kilometers. Another, parasite removal. Whale lice and barnacles live on a whale's skin, and the impact dislodges some of them. A third, play or social behavior, possibly all at once. A 40-ton whale leaps several meters into the air, expending enormous muscular effort. The question of why it expends so much energy is one science has not yet closed. The blue whale, the largest animal ever to have existed on Earth, is found in the Atlantic as well. 30 meters in length, 180 tons. Its heart is the size of a small car, its aorta wide enough for a child to swim through. Yet the blue whale feeds on krill, tiny crustaceans about a centimeter long. Each day it consumes roughly 4 tons of krill. The largest animal on the planet survives on one of the smallest, and the productivity of the Atlantic, the amount of krill it produces, literally supports the largest creature in the history of life on Earth. The fin whale, the second largest whale, is common in the Atlantic and known above all for its speed, up to 37 kilometers per hour, earning it the nickname Greyhound of the Ocean. The fin whale is asymmetrically colored. The right side of the lower jaw is white, the left side dark. This is the only known case of asymmetric coloration in large animals, and the explanation lies in hunting tactics. The fin whale attacks schools of fish from the right side, and the white patch on its right jaw startles the fish, driving them into a tight ball. There are also those in the Atlantic that use culture differently. Since 2020, young orcas off Gibraltar have been attacking yachts, breaking rudders, sometimes sinking vessels. No one fully understands why. Several orca populations inhabit the Atlantic, each specializing in its own prey and using its own hunting techniques. Norwegian orcas hunt herring, driving them into a tight ball at the surface, stunning them with tail strikes, then eating them. Antarctic orcas specialize in seals. The Gibraltar orcas in recent years have attracted unexpected notoriety. Since roughly 2020, young individuals approach yachts, attack rudders, and sometimes sink vessels. Interpretations diverge. Play behavior that has become a social fashion within the population, or a defensive reaction following a negative experience. Orcas learn and pass behavior to others. Again, culture. Again, the transmission of information between individuals. The Atlantic bluefin tuna is a fish that can weigh more than 6 kilograms and reach speeds of up to 70 kilometers per hour. It is a warm-blooded fish, a very rare adaptation that allows it to maintain body temperature above that of the surrounding water. It is precisely this warm-bloodedness that enabled the tuna to hunt in cold, productive waters where most other large fish do not venture. The bluefin tuna crosses the entire Atlantic, from the shores of North America to the Mediterranean and back. Tagged individuals were intercepted off the coast of Spain within weeks of being tagged off Newfoundland. It is the iconic fish of the Atlantic and simultaneously a symbol of overfishing. Its numbers collapsed in the 20th century due to commercial fishing. Recovery is proceeding slowly under strict quotas, and the species remains vulnerable. Sharks in the Atlantic are not one story but dozens. The great white shark occurs in temperate waters on both sides of the ocean, off the New England coast, off the Azores, off the coast of South Africa. The hammerhead shark in tropical and subtropical Atlantic waters is among the most social, forming schools of hundreds. The cat shark stays close to the bottom. The blue shark, in the open ocean, slender, swift, traveling thousands of kilometers. The whale shark, the largest fish in the world, filters plankton off the coasts of Belize and West Africa. Each species occupies its own niche, uses its own resource, and exists by its own rules. The Atlantic is large enough and diverse enough to hold them all. Great white sharks off Cape Cod in Massachusetts, a phenomenon that 20 years ago was rare and has now become annual. The reason? Seals. Gray seals off Cape Cod multiplied so dramatically after the Marine Mammal Protection Act of the 7077 that they became abundant. Great white sharks follow food. This is not an invasion or a catastrophe. This is an ecosystem restoring itself to its historical normal state. Great white sharks were always here. They were driven out, then their prey recovered, and they returned. This is good news, even if beachgoers perceive it differently. The surface of the Atlantic does not belong to predators alone. There are creatures that link the ocean to the land, literally crossing it entirely. The leatherback turtle, the largest living turtle weighing up to kilograms, nests on the beaches of Trinidad and Suriname and feeds off the coasts of Norway and Iceland. Every year it crosses the entire Atlantic basin back and forth. It has been tracked with satellite tags, and the routes are astonishing. The turtle does not travel in a straight line. It follows jellyfish, its primary food, which concentrates in specific places depending on currents and season. The turtle reads the ocean, its temperature, salinity, currents, and finds food where it is not on the map, but is in reality. Gray seals are large, males up to trusted kilograms, and noisy. On haulouts, they roar and fight, creating an impression of total chaos. Females give birth to one white pup and nurse it for 3 to 4 weeks on milk of extraordinary richness. Then they leave. The pup remains alone, molts, learns to swim. This is its first test without a mother, without experience, with a shark somewhere nearby. The walrus in the North Atlantic, the Atlantic subspecies, considerably less numerous than the Pacific, lives in Arctic and subarctic waters off the coasts of Greenland, Svalbard, and Canada. Their tusks are not weapons for hunting, but a tool for hauling out on ice, and a social signal. Tusk length indicates a male status. Walruses feed on mollusks, diving to the bottom, finding bivalves by scent, and sucking out their contents through powerful lips, leaving the shells intact. This is a highly specific hunting technique requiring great strength and precise control. Several species of albatross occur in the Atlantic, above all the wandering albatross and the black-browed albatross. The wandering albatross is the bird with the greatest wingspan of any living bird, up to 3 meters. It barely flaps its wings in flight, using a technique called dynamic soaring. It glides down the slope of a wave, builds speed, rises on the updraft above the crest, and glides down again. This allows it to cover thousands of kilometers at almost no energy cost. An albatross can circumnavigate the South Atlantic in a few weeks, barely landing. Young birds do not land for years at a stretch. The first years of their lives are spent entirely in the air and over water. Northern gannets form colonies of tens of thousands of birds on the cliffs of the North Atlantic. Their hunting is among the most spectacular in the bird world. A gannet spots a fish from a height of meters, folds its wings into an arrow shape, and dives at speeds up to kilometers per hour. The impact on the water at such speed should kill the bird, but special air sacs beneath the skin of the face and breast absorb the shock, while the nostrils are closed from the inside. The gannet enters the water like a projectile, catches fish at depths up to meters, then surfaces, swallows its catch, and takes off again. Murres, puffins, gulls, petrels, terns, the seabird colonies on the cliffs of Iceland, the Faroe Islands, Scotland, and Newfoundland hold millions of nesting birds. The puffin, with its orange beak, symbol of the North Atlantic, digs a burrow in soft ground at the clifftop and returns to it each year. Underwater it flies, beating its wings exactly as in air, and can dive to 60 meters. In its beak it holds up to 20 fish at a time, pinning the already caught ones with its tongue against the palate while catching the next. This requires a uniquely structured mouth that evolution has been building for millions of years. But in the Atlantic, there is a place that has no shores at all. Things go there and do not return. Only their children return. The Sargasso Sea is the only sea in the world without shores. It is bounded not by land but by currents, the Gulf Stream to the west, the North Atlantic Current to the north, the Canary Current to the east, the North Equatorial Current to the south. Within this ring, relatively calm, warm, salty water covered by vast mats of sargassum seaweed. The seaweed floats freely, unattached to the bottom, and beneath it is an entire ecosystem. Fish, crabs, shrimp, octopuses. Everything is colored like the seaweed, yellow-brown, mottled. This is camouflage that nature invented specifically for this place. The exact spawning site of the European eel has yet to be found. No spawning adult eel has ever been observed in the wild. It leaves and does not return. Only its offspring return. The European eel spawns in the Sargasso Sea. This is one of the most mysterious migrations in nature. Eels from the rivers of Europe, from the Rhine, from the Seine, from the Danube, as they mature, transform from yellow to silver, stop feeding, and head to sea. They swim across the entire Atlantic, sem nor to vosim nol kilometers, and spawn somewhere in the Sargasso Sea, then die. The larvae, transparent and leaf-shaped, nothing like eels, drift with the current back to the shores of Europe. The journey takes 1 to 2 years, and when they reach river mouths and swim upstream, the cycle closes. How exactly the eel navigates in the open ocean is still unknown. In the tropical Atlantic, where sailing ships were stranded for weeks in calms, nature found its own solutions. The zone between the two trade wind systems, the intertropical convergence zone, has long been known to sailors as the horse latitudes. Windless, hot, mirror still water. But nature likes this calm. Flying fish, dolphins, sea turtles concentrate here, and the warm, still water is rich with life, if you look closely enough. The flying fish is one of the most unexpected sights of the open ocean. Startled by a predator, it accelerates underwater, leaps out, and spreads its pectoral fins, which function like wings. The fish glides over the surface for up to 12 meters, sometimes touching the water with its tail for an extra boost. This is not true flight. It cannot actively beat its fins, but it is enough to escape from a tuna, from a dolphin, from any pursuer that cannot leave the water. The flying fish has found a niche that literally exists between two environments. Dolphins in the Atlantic are several species, each with its own way of life. The common dolphin, the most numerous, forms schools of thousands and feeds in the upper water column. The striped dolphin in the Mediterranean and eastern Atlantic. The bottlenose dolphin stays near shore, intelligent, social, with long memory. The Atlantic white-sided dolphin, large, in cold waters. Pilot whales form large pods and periodically strand themselves on beaches. Why pilot whales strand is one of the most persistent questions in cetacean science. Illness of the pod's leader, whom the others follow even onto the shore. Acoustic disorientation from military sonars. Disruption of geomagnetic navigation. None of the theories has been definitively closed. Every night, several billion tons of creatures rise from the darkness toward the ocean's surface. In the morning, they sink back down. This is the largest daily movement of living organisms on Earth, and it happens invisibly, right now. Between the surface and the floor of the Atlantic, an average of 10 kilometers of water. And this is not empty space. It is a multi-layered system in which every 100 meters of depth brings different pressure, different temperature, different amounts of light, and different creatures. Light disappears at roughly meters. Below that mark, no solar photon penetrates. Below meters, perpetual cold of about 10 degrees throughout the ocean, regardless of latitude or season. Below 1,000 meters, pressure that crushes any unprotected object in seconds. And despite all this, life is everywhere, at every depth, in every layer, in conditions that from the surface seem incompatible with the existence of anything. The mesopelagic zone, from Devesti to Aden, no meters depth, is probably the least studied part of the ocean relative to its biological importance. Here live creatures that almost no one has seen alive. They live too deep for ordinary observation and are too fragile to survive being brought to the surface. But there are vast numbers of them. By some estimates, the biomass of fish in the mesopelagic zone of the world's oceans exceeds the biomass of all commercial fishing that humanity conducts in surface waters. This is a parallel ocean, existing right below the one we know, and we know almost nothing about it. Vertical migration is one of the most large-scale daily phenomena on the planet. Every evening when the surface grows dark, enormous numbers of creatures rise from the mesopelagic zone upward into the surface waters where they can feed in the dark of night. Every morning, when it grows light, they sink back down into the cold and dark where surface predators cannot see them. This happens every 24 hours across the entire ocean simultaneously. The volume of living mass making this daily ascent and descent by some estimates amounts to several billion tons. The logic is simple. During the day, the surface is bright, and it is easy to become prey for a visually hunting predator. At night, it is dark. One can come out and eat. Plankton, on which small fish and crustaceans feed, concentrates at the surface where there is light for photosynthesis. In the evening, rise up and eat. In the morning, sink down and hide. This is an evolutionary solution to the problem of survival found millions of years ago, and it is so effective that hundreds of species use it simultaneously. Luminescent creatures in the mesopelagic zone of the Atlantic are not the exception, but the rule. By some estimates, 70 to 80% of organisms in this zone can produce their own light, bioluminescence. This is a chemical reaction. The protein luciferin is oxidized by the enzyme luciferase, and light is emitted, without heat, without electricity, without batteries. Pure chemistry refined over hundreds of millions of years. The color of the glow is most often blue or green. These wavelengths travel best in water. Red light is absorbed quickly, so red creatures in the depths look black and are invisible to most predators. Anglerfish, the fish that became a symbol of the deep ocean. Females have a bioluminescent appendage above the head, the elysium, which glows in the dark and serves as a lure. A small fish or crustacean sees the light and swims toward it, and finds itself within range of an enormous mouth, a trap that operates on the prey's own eyesight. In different anglerfish species, the elysium is constructed differently. Some swing it like a pendulum, others hold it still, others imitate the movement of small creatures. This is not merely a lamp, but a hunting instrument with fine tuning. Male anglerfish are many times smaller than females, tens of times so. When a male finds a female, which in the darkness of the vast ocean is itself an extremely difficult task, he bites her skin and literally fuses with her. His circulatory system connects with hers. His organs atrophy except the testes. He becomes a parasitic appendage of the female, a source of sperm always at hand when spawning comes. Some females carry several males simultaneously. This sounds like science fiction, but it is simply a solution to the reproductive problem in a vast dark ocean where meeting a partner is a rarity. Deeper still, where light never reaches, a very different hunt is underway. The sperm whale is searching for squid. The giant squid, Architeuthis, reaches 13 to cheddar meters, including tentacles, and weighs up to 30 kilograms. Until the beginning of the 21st century, no one had ever filmed one alive. Only dead or dying individuals were found on shores. In 2000 Japanese scientists were the first to photograph a living giant squid in its natural environment. And in 2012, it was filmed for the first time on video at a depth of about 7 meters in the Pacific Ocean. In the Atlantic, it has been filmed far less often. What exactly it does at its depths, how it hunts and how it reproduces, is largely inference based on analysis of the stomach contents of sperm whales. The sperm whale is the primary squid hunter in the Atlantic. It dives deeper than any other mammal except beaked whales, to 3 kilometers and more, and remains underwater for up to 2 hours. On the skin of sperm whales are found circular scars from the suckers of giant squid, traces of a battle in the dark at a kilometer's depth that no one has ever witnessed, and probably never will. What happens during this encounter can only be reconstructed from the marks on the skin. The scars indicate that squid put up resistance, and the size of some of them suggests that squid can be far larger than those found dead. The sperm whale navigates in the dark with echolocation, the most powerful biological sound system on Earth. It produces clicks with an intensity of up to decibels, louder than a jet engine at close range. The sound reflects off objects and returns to the whale. A specialized organ in the sperm whale's head, filled with spermaceti, serves as an acoustic lens that focuses the sound into a narrow beam. The sperm whale sees with sound, obtaining a three-dimensional picture of its surroundings in complete darkness, with an accuracy unattainable by any other means. It locates a squid hundreds of meters away, determines its size, speed, and direction of movement, and attacks. Beaked whales, the most enigmatic of the cetaceans, dive deeper and longer than sperm whales. The Cuvier's beaked whale set a record dive of 2,992 meters and spent 42 minutes underwater, absolute records among all studied marine mammals. They feed mainly on deep-sea squid and fish. On the surface, beaked whales spend the minimum of time. They surface briefly to breathe, then go back down. They are rarely encountered by researchers precisely because they are almost always where researchers cannot reach. Mesopelagic fish, small, often with enormous eyes or photophores, light-producing organs along the body. Photophores serve different purposes depending on the species, attracting mates or counter-illumination camouflage from below. When a fish glows from beneath as brightly as the light filtering through the water from above, its belly casts no shadow and renders the fish invisible to predators from below. This is called counter-illumination, one of the most sophisticated forms of camouflage in nature. The giant isopod, a deep-sea relative of the common pillbug, only to times larger, up to 7 centimeters long, with rigid, segmented armor and enormous compound eyes. It feeds on carrion, the remains of large animals sinking to the bottom, and can go without food for years if prey is absent. In captivity, a giant isopod went without food for 5 years and remained alive. This extreme fasting, which from a physiological standpoint should not be possible, is normal for a creature that lives where food arrives irregularly and unpredictably. Jellyfish in the water column of the Atlantic are one of the most underestimated groups. They are usually seen as passive, current-drifting creatures, and this is partly true. But jellyfish actively hunt, using stinging cells on their tentacles, and some species hunt fish. The Portuguese man-of-war is strictly speaking not a jellyfish but a siphonophore, a colony of many specialized individuals. The float sailing at the surface is one organism. The tentacles up to 50 meters long are other organisms. The cells that paralyze prey are yet others. It is a colony functioning as a single animal, though composed of many separate individuals. The blue color of the man-of-war is not coincidental. Blue against the blue surface of the water is less visible to predators from above. Siphonophores in the depths of the Atlantic can be far larger than the Portuguese man-of-war. Some species reach up to 57 meters in length, making them among the longest animals on Earth, longer than the blue whale. They are not widely known because they live deep and are extremely fragile. Any attempt to bring them to the surface ends in disintegration. They are studied with remotely operated vehicles, and every time a submersible descends into the depths of the Atlantic, the probability of encountering something science has not yet described remains high. The bathypelagic zone, from Agenol to Chetirinol meters, complete darkness, constant cold of about 2 degrees, pressure from stow to Chetirista atmospheres. There is no photosynthesis here. All energy arrives from above in the form of marine snow, constantly sinking particles, remnants of dead planktonic organisms, fecal pellets, mucus. This slow rain of organic matter feeds everything that lives at depth. Marine snow seems insignificant, tiny particles barely moving in the water, but across the entire ocean, it is an enormous flux of organic carbon sinking from the surface to the bottom, thereby removing carbon dioxide from the atmosphere. This is called the biological carbon pump, and the Atlantic is one of its principal operating zones. The viperfish, Chaliotis, has fangs so long they cannot fit inside the mouth and protrude outward. Its mouth opens 120 degrees, and in that moment the spine bends so the head tilts all the way back. This allows it to swallow prey comparable in size to itself. In a world of perpetual food scarcity, this ability is critical. Do not miss whatever comes along, whatever its size. The hatchetfish, tiny, silvery, with enormous upward-directed eyes and a row of photophores along the lower edge of the body, illustrates several adaptations at once. Eyes directed upward because the threat most often comes from below. A larger predator sees the fish as a silhouette against the faint light from above. Photophores below create the counter-illumination effect. The silvery scales reflect light from every direction, making the fish less visible at any angle. This is a set of solutions, each of which individually increases the chances of survival, and together they create a creature nearly perfectly adapted to its niche. The gulper eel looks like something from a nightmare, an enormous mouth with a stretchable stomach and a tiny tail with a glowing organ at the tip. This animal can swallow prey significantly larger than itself. The glowing tail probably serves as a lure, like the anglerfish's Elysium, only from behind. The gulper eel moves slowly through the darkness, its tail flickering, and something curious swims toward the light and is swallowed. This is an evolutionary solution to the hunting problem in an environment where food is scarce and encounters rare. Make prey come to you. The Dumbo octopus, Grimpoteuthis, got its nickname from its ears, two fins on the sides of the head that it flaps like the cartoon elephant. It lives at depths from 300 to 700 meters and is one of the deepest dwelling of all octopuses. It does not squirt ink as a defense. At such depth, darkness makes that pointless, and does not hunt from ambush. The Dumbo octopus drifts slowly above the bottom, finding prey, worms, crustaceans, bivalves, and swallows it whole, unlike most octopuses that tear their prey apart. This is a slow, calm, almost passive creature in a world where there is nowhere to hurry because prey does not escape quickly. Sharks in the depths of the Atlantic are species most people have never heard of. The Greenland shark lives in the cold depths of the North Atlantic and is one of the longest-lived vertebrates on the planet. Its age is determined by radiocarbon analysis of the eye lens, and the numbers obtained are difficult to accept as real. One specimen caught in the North Atlantic was estimated at 400 to 500 years old. This shark was born in the time of Ivan the Terrible, or even earlier, and was swimming these waters when Columbus had not yet crossed the Atlantic. Its metabolism is so slow that it is almost motionless. Its speed is about kilometer per hour, and it mostly eats whatever happens to come near without pursuing prey. On the corneas of most adult Greenland sharks live parasitic copepods that slowly destroy the corneal tissue. The shark is nearly blind. This does not prevent it from living for centuries, because in the dark, cold waters where it lives, eyesight is not the primary sense. Among the other inhabitants of these same depths, the ghost shark, a deep-sea species from the chimera family, strictly speaking, not a shark but a distant relative. It has a long snout with electroreceptors that detect the weak electric fields produced by prey in the substrate. The chimera finds mollusks and worms without seeing them or smelling them, by sensing only their bioelectricity. This is a navigational system that humans do not have and are only beginning to imitate in technology. A small deep-sea shark of the genus Centrophorus with enormous green eyes is built differently. Its liver occupies up to % of its body mass and contains squalene, an oily substance that serves as ballast in place of a swim bladder, which sharks do not have. They control buoyancy through liver fat. Centrophorus lives at depths from 20 to 200 meters, hunts small fish and squid, and in the 20th century became a victim of the cosmetic industry. Its squalene was heavily harvested, and many species were driven toward extinction before their population sizes had even been assessed. This is a classic story of deep-sea exploitation. Harvest before you study. The intermediate waters of the Atlantic at depths from 600 to 1500 meters contain a special layer that forms in the Mediterranean Sea. Mediterranean water is very salty due to intense evaporation. Flowing out through the Strait of Gibraltar into the Atlantic, it sinks, by virtue of its density, to a specific depth and forms there a horizontal layer that can be traced by its elevated salinity for thousands of kilometers from Gibraltar. This is Mediterranean water traveling through the Atlantic and preserving its identity for decades. The Atlantic keeps the history of every sea that flows into it, in layers of water moving slowly and far. At depths from 200 to 69 meters, where sunlight does not reach, live deep-sea corals, creatures entirely unlike their tropical relatives at the surface. They do not require photosynthetic algae and feed on organic particles carried by currents. They grow slowly, a few millimeters per year, and live for centuries. The Lophelia pertusa reefs off the coasts of Norway and in the North Atlantic are among the largest structures built by living organisms in this region. They serve as home to hundreds of species of fish, worms, echinoderms, and crustaceans. A deep-sea reef is an oasis of biodiversity in relatively nutrient-poor waters, existing in darkness by rules we are barely beginning to understand. Sea spiders, pycnogonids, inhabit the depths of the Atlantic and look improbable even by deep-sea standards. These are arthropods with a tiny body and long, slender legs. The body is so small that the digestive and reproductive organs are located in the legs themselves. There is no room for them in the body. Some deep-sea species reach tritsit to sorok centimeters in leg span. In shallow water, sea spiders are small and unnoticed. In the deep, they become giants, and this phenomenon is called deep-sea gigantism. It has been noted in many groups: isopods, amphipods, sea spiders. Why depth produces gigantism has several proposed answers. Cold metabolism allows longer life and growth, fewer predators, greater access to oxygen in cold water. None of the theories has become definitive. The acoustics of the deep ocean are a phenomenon rarely discussed. In the Atlantic, there exists the SOFAR channel, a layer of water at about 9 meters depth where the speed of sound is at a minimum due to a special combination of temperature and pressure. Sound that enters this layer does not scatter, but is contained within it and propagates thousands of kilometers with little attenuation. Blue whales and fin whales produce infrasound below the threshold of human hearing that travels through the SOFAR channel across the entire Atlantic. A whale off Canada can hear a whale off Portugal. This is a planetary acoustic system, nature's telephone, which whales were using long before humans invented the telegraph. But the floor of the Atlantic now bears the marks of a different era, one its former inhabitants did not know. Noise pollution of the ocean is one of the least visible but most serious threats to marine life in the Atlantic. Commercial shipping produces low-frequency noise that overlaps precisely those frequencies on which whales communicate. Over the past 50 years, the level of low-frequency noise in the North Atlantic has risen roughly tenfold. For whales, this means that the radius of effective communication has shrunk. Where a whale once heard its kin thousands of kilometers away, it now hears them hundreds away. This does not kill immediately. It isolates, makes finding a mate harder, hampers coordination within a pod, disrupts navigation. Slow pressure on systems that evolved in silence over millions of years. Plastic in the water column of the Atlantic is another reality that cannot be avoided. Most plastic in the ocean is found not at the surface, but in the water column and on the bottom. It sinks slowly, becoming coated with biofilm and microorganisms that make it heavier. Plastic particles have been found at depths of several thousand meters, in the stomachs of deep-sea fish, in the tissues of creatures that never rise to the surface. Microplastic, particles smaller than 5 millimeters, is present in plankton, in filter feeders, in food chains that never touch the surface. This is contamination that has entered the system throughout, from the surface to the abyss. Squid in the open Atlantic and adjacent seas produce synchronized flashes of light directed not for camouflage and not for luring prey, but for communication with other individuals of their species. Each flash carries information about species identity, readiness to reproduce, position in space. This is a language that exists in the darkness of the ocean, a language we do not understand and have barely begun to decode. Sperm whales in the Atlantic live in matrilineal family groups. Young animals and calves gather around elder females, while adult males go off and live more solitary lives. Family groups communicate through coded clicks specific to each family. This is a dialect. Different families have different codes, like different accents within one language. Calves learn their family's code in the first months of life, a cultural transfer of information from mother to offspring and from family to family, occurring in the dark waters of the Atlantic right now. The abyssal plain of the Atlantic is one of the flattest places on Earth. It formed over millions of years. Sediments settled to the bottom slowly and evenly, smoothing the relief. The rate of sediment accumulation is about 1 centimeter per null years. This means that the top centimeter of substrate on the floor of the Atlantic holds the last decade null years of the planet's history, recorded in particles, pollen from plants that have already gone extinct, shells of foraminifera, tiny single-celled organisms with calcareous cases whose chemical composition reflects the temperature of the water at the time of their life, volcanic ash from eruptions that occurred thousands of years ago. From the ratio of oxygen isotopes in foraminifera shells, scientists reconstruct ocean temperatures at different periods to fractions of a degree over millions of years. This is paleoclimatology, the science of past climate, which uses the ocean floor as a textbook. The Atlantic floor holds records of ice ages, of warm periods, of mass extinctions. In every cubic centimeter of sediment, a millennium of information. The mid-Atlantic ridge on the ocean floor is not merely a mountain range, but the place where new ocean crust is born. Along the ridge's axis runs a rift valley from which magma is constantly extruded. It cools, solidifies, becomes basalt, and spreads to either side of the axis, carrying everything above it along. All the crust of the Atlantic Ocean is relatively young. Near the shores of North America and Africa, it is older than near the ridge. But even there, it is no more than 20 million years old. In the scale of geological time, this is youth. But the most unexpected lesson about the limits of life came not from surface waters, but from the darkest, hottest, most poisonous place in the Atlantic. Hydrothermal vents, black smokers, were discovered in the region of the mid-Atlantic ridge and overturned the understanding of where life is possible. Water seeps through cracks in the basalt, is heated by magma to 400 degrees and above, dissolves minerals from the rock, and erupts back out through the vent openings. On contact with the cold bottom water, the minerals precipitate instantly, forming black clouds, hence the name. The vent gradually builds up a chimney of minerals, a meter high, 10 meters, sometimes 60 meters, and around these chimneys, life that does not depend on sunlight in any form. The discovery of hydrothermal ecosystems changed the understanding of the possible limits of life as radically as the discovery of the New World changed geography. Chemosynthesis, photosynthesis in reverse. The energy source is not solar photons, but chemical reactions. The oxidation of hydrogen sulfide, methane, hydrogen. Bacteria capable of this live around hydrothermal vents in enormous numbers and form the base of a food chain that does not begin with the sun. Tube worms, riftia, up to meters long, with no mouth or stomach, live in symbiosis with chemosynthetic bacteria, filling a specialized organ inside the worm. The worm supplies the bacteria with oxygen and hydrogen sulfide from the water. The bacteria produce the organic matter on which the worm feeds, a closed system that needs nothing except geothermal heat. At Atlantic hydrothermal vents, tube worms form dense thickets. White tubes, red feathery gills at the ends. Among them, crabs, snails, mussels, octopuses, fish. A fully functioning ecosystem in a place where traditional biology would expect to find nothing. Boiling water, hydrogen sulfide, darkness, pressure, and life that is not stopped but nourished by all of this. The Pompeii worm lives directly on the walls of black smokers at temperatures up to -80 degrees Celsius. It is one of the most heat-tolerant multicellular animals on Earth. Its back is covered with bacteria, forming a kind of thermally insulating coating. The head of the Pompeii worm is in relatively cool water of about 20 degrees, while its tail is attached to the wall of the vent, a temperature gradient of 17 degrees along the length of a single animal. The mechanism allowing it to withstand this is not fully understood. A blind white crab with unusually long legs lives immediately adjacent to the hydrothermal vents. Its eyes degenerated in the course of evolution. In the dark, they are useless. But it has developed chemical receptors. It senses the concentrations of chemical substances in the water and navigates by them in the dark. This is navigation by scent in a space where sight is impossible. The Atlantic abyss, the plain deeper than 39 meters, is covered with soft sediment in which live creatures that are nearly impossible to see without specialized instruments. Polychaete worms, bristled, burrowing, crawling across the surface. Nematodes, round worms less than a millimeter in length, of which hundreds may be found in a single square centimeter of the surface sediment layer. Brittle stars, ophiuroids, crawl across the bottom on long, slender arms. Sea cucumbers, holothurians, move slowly, sucking in sediment and extracting organic matter from it. This is a benthic community existing on the energy of marine snow, the organic matter falling from above. Sea cucumbers in the deep parts of the Atlantic form processions, long strings of animals moving in one direction. Why they do this has not been established. Perhaps they follow a current carrying more organic matter. Perhaps they react to the chemical trail of the animal ahead, or perhaps for reasons we do not yet understand. A creature resembling a bag of water turns out to be one of the most successful inhabitants of the darkest part of the planet. Deep-sea fish on the bottom, the lancetfish, the chimera, other species, move slowly and economically. Many of them have gelatinous bodies with high water content. This reduces density and lowers the energy expenditure of maintaining position in the water. Muscle mass is minimal, bones are thin and light, skin may be nearly transparent. These are creatures optimized for minimal energy consumption in an environment where every calorie counts. Hadal zones, deeper than 69 meters, are represented in the Atlantic by several trenches. The Puerto Rico Trench is the deepest point in the Atlantic Ocean. 376 meters. This is a point roughly 2.5 kilometers deeper than the height of Everest. If Everest were placed on the floor of this trench, its summit would be 2.5 kilometers below the water's surface. The pressure there is about 230 atmospheres, the temperature roughly 2 degrees, and creatures live there. Amphipods in the Puerto Rico Trench, crustaceans resembling shrimp, adapted to ultra-high pressure. Their cells contain special stabilizing molecules, trimethylamine oxide, whose concentration increases with depth. This substance prevents deformation of proteins under pressure. Without it, protein molecules at high pressure change shape and stop functioning. The amphipods of hadal zones are chemically protected against pressure at the molecular level, an adaptation that allows life to exist where pressure is for 7 times atmospheric. Snailfish of the family Leporidae, record holders for depth among fish. In the Pacific, they have been filmed at depths greater than 4 meters. In the Atlantic, deeper than 7. They are transparent, gelatinous, with tiny eyes or none at all. Their bodies lack a swim bladder, Maintaining buoyancy would cost too much energy at such pressure. They hunt amphipods and small crustaceans concentrated in the trenches and stand at the top of the local food pyramid, predators in the deepest place in the ocean. The Puerto Rico Trench formed as a result of subduction. The Caribbean plate is descending beneath the North American plate, and it is precisely this zone that is the source of powerful earthquakes and tsunamis in the Caribbean region. An earthquake in the Atlantic off the coast of Portugal generated a tsunami that destroyed Lisbon. The Atlantic floor is not static. It moves, grinds, fractures, sinks, and this process is felt on the surface as waves crossing thousands of kilometers in a matter of hours. Seamounts are scattered across the entire floor of the Atlantic. These are extinct or dormant volcanoes rising from the bottom, but not reaching the surface. Life concentrates on their slopes. Currents sweeping around the seamount lift deep water rich in nutrients toward the surface. Around such summits feed tunas, sharks, sea turtles, drawn by the abundance of fish and squid. Deep-sea corals cover the slopes, creating reef structures in the dark. A seamount is an oasis of productivity in the midst of relatively sparse open water. On the surface, a different logic was at work. Where the resource seemed inexhaustible, it was exhausted. Quickly, irreversibly. The Grand Banks of Newfoundland in the North Atlantic were historically one of the richest fishing grounds in the world. Here the cold Labrador Current and the warm Gulf Stream meet, creating upwelling, the rise of deep water rich in nutrients. Plankton erupts, herring and capelin follow, then Atlantic cod, which had been fished here for centuries. The first European fishermen off Newfoundland described water literally boiling with fish. It was caught in baskets lowered over the side. It became the foundation of the economies of Northern Europe and North America for several centuries. The Canadian government closed the fishery entirely. The population had collapsed to 1% of its historical level. This is one of the largest fishery collapses in history, which happened not gradually but suddenly, when numbers fell below the point of no return. Atlantic cod has not fully recovered to this day, 30 years after the closure. The reason is an ecological trap. Where cod once lived, sea urchins and crustaceans are now abundant, because adult cod ate their larvae and regulated their numbers. Without cod, they multiplied, and now they themselves eat young cod. This is a trap with no obvious exit. The same story repeats with other species, only more slowly and almost invisibly. Atlantic salmon, wild, not farmed, spawns in the rivers of North America and Europe, goes to sea, feeds off the coasts of Greenland and the Faroe Islands, and returns to the very river where it was born. Its numbers over the past half-century have fallen catastrophically. Overfishing at sea and in rivers, destruction of spawning grounds, aquaculture producing diseases and parasites that spread to wild fish, climate change altering river temperatures. In some rivers where it spawned for centuries, it is gone. Migratory birds use the Atlantic as a route. The Arctic tern, champion of long-distance migration among all animals, every year flies from the Arctic to the Antarctic and back, and its route passes over the Atlantic. It is not a straight line. The tern uses wind systems, skirts calm zones, and flies a curve that on a map looks convoluted, but in reality is the optimal route. In a year, the Arctic tern covers approximately 100 kilometers. Over a lifetime of 30 years, the equivalent of several round trips to the moon and back. It lands only to nest, spending most of its life in the air and over water. The great shearwater nests on Tristan da Cunha, a tiny island in the South Atlantic, and feeds in the North Atlantic, flying thousands of kilometers back and forth each year. Its navigation relies on Earth's magnetic field, on the smell of dimethyl sulfide released by phytoplankton in productive areas, and probably on other cues we do not yet fully understand. A bird that finds a specific tiny island in a vast ocean after months of absence does so more precisely than any navigational instrument. The European eel is one of the most severely affected species in the Atlantic. Its numbers over the past 40 years have declined by 12%. The causes are not fully understood. Changes in oceanic currents carrying larvae, parasites introduced with aquaculture eels from Asia, overfishing, barriers on rivers in the form of dams preventing adult eels from descending to the sea. The eel is disappearing, and no one knows exactly how to stop it, because its life cycle is still not fully understood. Sunken ships on the floor of the Atlantic, thousands of vessels, wooden caravels of the 15th century, iron steamships of the 19th, steel ships of the 20th. Over time, they become part of the reef system, encrusted with corals, sponges, mussels, turning into a home for fish, octopuses, and crustaceans. A sunken ship in warm waters within a few decades becomes an artificial reef with its own ecosystem and its own food chain. The organic matter of the ship enters the local cycle. The metal rusts and releases iron, a valuable micronutrient often scarce in the tropical ocean. Mangrove forests on the Atlantic coastlines of the tropics, the shores of Brazil, West Africa, the Caribbean islands, are a critical transition zone between land and sea. In the mangrove thickets spawns an enormous proportion of the commercially important fish of the Atlantic. Larvae hide among the roots from predators of the open water. Juvenile fish develop there, young turtles, young sharks. The mangrove forest is the Atlantic's nursery, and it is being cleared for aquaculture ponds, for construction, for palm plantations at a rate that makes the future of the Atlantic's commercial fish less predictable with each passing year. The Sargasso Sea is experiencing changes that receive less attention than they deserve. On one hand, warming water is altering the nutrient regime and affecting the growth of the seaweed. On the other, since 2011, gigantic accumulations of sargassum have been appearing in the Atlantic, washed onto the shores of Caribbean islands and Mexico in quantities never seen before. This is a different type of sargassum from the tropical Atlantic, where nutrient runoff from the Amazon has increased due to deforestation. Nutrients flow into the ocean, the sargassum proliferates, is carried to shores, rots, releases hydrogen sulfide, kills coastal reefs and fish. A change on land echoes in the open ocean thousands of kilometers away. Deep-sea mining is a threat now much discussed. On the floor of the Atlantic and other oceans lie polymetallic nodules, concretions of manganese, nickel, cobalt, and copper whose formation takes millions of years, a few millimeters of accretion per year around some grain of material. Metallurgical companies want to mine them. The technology exists. The International Seabed Authority issues exploration licenses. What will happen to abyssal ecosystems under industrial extraction is unknown because it has never been tested at such scale. Recovery of abyssal communities, if it is even possible, will take thousands of years at the rate of sediment accumulation of a centimeter per millennium. This is a decision being made now, and that cannot be undone. Climate change is altering the Atlantic faster than any other major Earth ecosystem has changed in the observed period. The temperature of surface waters is rising. The thermocline, the boundary between warm surface water and cold deep water, is becoming more pronounced. This impedes mixing of water, meaning fewer nutrients rise from the depths to the surface where photosynthesis is needed. The productivity of surface waters is declining in parts of the Atlantic. Less plankton, less fish. Less fish means fewer whales, tuna, birds. AMOC, the Atlantic Meridional Overturning Circulation, that same conveyor belt, is slowing, and this has been established. The melting of the Greenland ice sheet is adding to the North Atlantic enormous quantities of fresh water, which is lighter than salt water and does not sink the way cooled salt water is supposed to sink near the northern shores. If cold water does not sink, the conveyor slows. If the conveyor slows, the Gulf Stream weakens. If the Gulf Stream weakens, Northern Europe cools. This is not a speculative scenario, but a process already underway. How quickly and how far it will go is one of the most important questions in climatology right now. Coral reefs in the tropical Atlantic, in the Caribbean Sea, and the Florida Straits are under pressure from several factors simultaneously. Warming water causes bleaching. Corals expel the symbiotic algae that give them their color and most of their nutrition, and turn white. If bleaching lasts more than a few weeks, the coral dies. Ocean acidification. The increase in acidity due to absorption of carbon dioxide makes the water less saturated with calcium carbonate, from which corals build their skeletons. In 2023, a massive bleaching event occurred in the Caribbean Sea. Water temperatures broke records, and some reefs lost a significant portion of their living cover. Caribbean reefs are now in the worst condition in the entire period of observation. And yet the Atlantic is alive. This is important to say, not as reassurance, but as fact. Humpback whale populations in the North Atlantic have recovered from near total destruction by whalers, from a few hundred individuals to tens of thousands, thanks to the moratorium on commercial whaling adopted in 2000. Atlantic bluefin tuna in the North Atlantic is showing signs of recovery following the introduction of strict quotas. Gray seals off the coast of Britain have multiplied to the point where they have become a source of controversy about fisheries management. This is not a victory or the end of the story. It is evidence that when the pressure is removed, nature recovers. Not always, not everything, not immediately, but it recovers. The Atlantic is a system that has existed in one form or another for a billion years, long before the current configuration. It survived mass extinctions, ice ages, the collision of continents, and will outlast what is happening now in the geological sense. The question is not whether the Atlantic will survive. The question is what it will look like and whether the creatures that make it the Atlantic today will still be in it. The humpback whale singing in the dark, the sperm whale hunting at a kilometer's depth, the Arctic tern flying from one end of the planet to the other, the tube worm at the hydrothermal vent that needs no sun, the Greenland shark that is pissote years old. This is all the Atlantic. All of it is in question. Please write in the comments how this story struck you. I want to know whether it reached you. Do you think Canada made the right call in 1992 when it closed the Atlantic cod fishery entirely? Or was it a decision that came too late to bring the fish back? And tell me this too. Do you find it easier to watch the video horizontally or vertically for phone screens?